Hey everyone. So we just have two more examples to do really quickly in section 9.2, which again is just solving quadratic equations by graphing. Um, this first example here is really super quick. They just want you to find the zeros of f. So whether you do it like this way, um, minus x minus 2, or you just go ahead and factor, because this right here is factorable. Again, just to kind of give ourselves a little bit of practice with factoring, that would be minus 2, and that would be plus 1. And then remember that zero product property where we would just set each of these equal to 0, and then solve. So you would have x equals 3, x equals 2, and then x equals negative 1. So these are all of your zeros, just solving them. But as you guys can see, if you just look where they're each crossing, because I believe that for the most part they're giving you pictures to look at. So you can just see that this is crossing at x equals negative 1, this is crossing at x equals 2, and this is crossing at x equals 3. So that example is really, really super quick. You're just basically figuring out where it's crossing on the picture. The last example that we want to go through really quickly is we're looking at a football player who kicks a football 2 feet above the ground. And it has an initial vertical velocity of 75 feet per second. So here's our function, negative 16t squared plus 75t plus 2. And just like they said, plus 2, that's the starting height. So if you kind of think about where a football is being kicked, right? Like you have your little person who's kicking it, like the ball has to be off of the ground just a little ways in order for that person to kick it. So it's a really bad picture, but you get the general idea. So what's happening here is it says, part A says find the height of the football each second after it is kicked. So they basically want you to, first off, go ahead, take 0 and plug it in for each of the t's. So negative 16 times 0 squared plus 75 times 0 plus 2. Plug it in, and when you do that, you come up with a height of 2 feet, which makes sense because you haven't quite kicked it yet, and it's only 2 feet above the ground. So again, that initial height is 2 feet above the ground. Go ahead, take 1 and plug it in. Come up with, let's see, 1 squared plus 75 times 1 plus 2. So when you plug 1 in, you come up with, let's see, negative 16 times 1 squared plus 75 times 1 plus 2. I believe you come up with 61. So that just means 1 second after the ball is kicked, it is 61 feet in the air. I want you guys to go through and figure out the rest of them. I can finish this question up with you tomorrow. Actually, you know what? I'll just finish it now. When you plug 2 in, so 2 seconds after it's kicked, again, you're just taking the 2 and you're plugging it in for each of the x's. You should come up with, let's see, 88. Okay, so 2, 61, 88. What about when we plug 3 in? What did I come up with there? I had 83. Okay, so here, one thing to notice, this went from 61 feet to 88 feet to 83 feet. So approximately 2 seconds, maybe somewhere between 1 and 2 or 2 and 3, that ball finally hits its vertex. It finally hits that maximum height, because all of a sudden you're going 61, 88, now it's coming back down. So just make sure that you keep plugging in until you come up with 0 or negative number. And I believe that would be the next one. So if you start plugging in 5, you have negative 16 times 5 squared plus 75 times 5. And then that would be plus 2. Yeah. So as soon as you plug 5 in, you're at negative 23 feet. So somewhere between 4 and 5 seconds is when that ball finally hits the ground. Now, part B asks us, use the results of part A to estimate when the height of the football is 50 feet. Okay, so this is a really great question. We got to start thinking, and they're just asking us to estimate. We got to start thinking about, okay, first off, what approximate intervals is this ball going to be about 50 feet? So when I look here between 2 and 61, somewhere between 1 and 2 seconds, or excuse me, 0 and 1 seconds is when that ball would be about 50 feet. Probably a little bit closer to 1. But yeah, somewhere between, I guess I would say close to 1 second is the first time that it hits about 50 feet. And then we're looking again about here, 83 to 46. So between 3 and 4 seconds, probably closer to 4 seconds for this second one here. Okay, then for part C, it says using a graph. After how many seconds is the football? So after how many seconds is the football 50 feet above the ground? Okay, so here's what they basically want us to do. They want the height to be 50. And they want you to take this negative 16t squared plus 75t plus 2. Remember, the only way for us to kind of start solving a problem like this is to get 50 over here on the other side. So negative 16t squared plus 75t, and then that would be minus 48. You guys, basically what happened here is they took the original graph, right? So that started, it went through 2. So probably looks somewhere, something like that, maybe. But what they basically did is they took this entire graph and they moved it down 50 units. So that you're only looking at the points where this ball is above 50. Okay, so their goal here is to basically have you figure out like where is the ball above 50 here, and then where does it cross 50 again for this second one here. So what I decided to do, just because this is a really, really hard example, like you can't take a factor of 16 out, and then to be able to do AC split, those numbers are going to super, super big. So I'm just taking a different route, and I went through and did Desmos. So I just plugged this function in. I plugged in h equals negative 16t squared plus 75 minus 48. And again, you're just going through and you're figuring out where these are crossing. So, I mean, here I'm at about 0.765, and here I'm at about 3.9. So after how many seconds? What did they say? T equals 0.765 and t equals, where is this one here? 3.923. Look at these times here. Right? You've got about 0.8 seconds, which is really close to 1. And you've got 3.9 seconds, which is really close to 4 seconds. So they basically wanted you to, in part B, come up with an approximation so that you had an idea, an estimate of where or how long this ball is going to be above 50 seconds or when it hits 50 seconds. And then they have you do an exact. Okay, so just to kind of, again, develop a little bit of that number sense. All right, you guys should be all ready to finish up the assignment for section 9-2. If you have any questions, let me know. Otherwise, I will see you guys tomorrow. Have a great night.